All right. So thank you. So the next talk is from Kyungeon Choi, who is at UT on ServiceX, which is a system for on-demand data transformation and delivery.
Okay, thanks. So hello, my name is Kyungeon, and I am a postdoc at UT Austin. And today I want to talk about an interesting service, so-called ServiceX, which provides a new way of accessing data from the grid by doing on-demand data transformation on the fly and delivered to the user in various formats. So what is ServiceX? Basically, ServiceX does data delivery from the grid to users, but with these key features. It can perform pre-selection and also column selection of the input data so that all the information a user wants can be delivered. And also various kinds of output formats are supported. And such processes are called as a transformation, which is done on the fly. And the service is experiment agnostic, so it can be basically attached to the data sets from different experiments. And the data delivery is on demand. So once you make a request, it starts transformation and delivers the output to you or to the place you designated. And the diagram here I'm showing is a workflow of Atlas Run 2 derivation production, which is from reconstructed data, so-called AOD, and to slimmed and or skimmed data called DAOD, and then make a antipole, flat antipoles, and then get results, which is shown in black lines. And ServiceX basically can be placed anywhere in the workflow depending on the user's need. For example, if you need only a few branches or columns from DOD, ServiceX can deliver those columns after your pre-selection in the format you specified. Or if your nicest antipole is an order of terabyte, not gigabyte, so you want to put in on the grid, and then you can ServiceX can basically deliver the same like for the information you need. And as mentioned in the previous slide, ServiceX can take input data in the format of AOD or root flat antipole, and then it delivers user selected columns in various ways. Basically, you can download outputs as a Apache Parquet or root antipole, or in the format of arrays such as Akkad array or Pandas data frame. Or you can stream Apache Arrow to Kafka message broker, then consume later on. And here I put all the logos of tools used by ServiceX, which is not inclusive, but it uses many industry standard tools and also HEP tools like Omnud and Akkad array. And first of all, whole service is containerized as Docker images and then deployed into the Kubernetes cluster, which is a container orchestration platform. So the core job like data transformation can be easily scaled to many workers. And the deployment into a Kubernetes cluster is done by Helm chart, so you can easily manipulate the configuration file of your ServiceX deployment. And as you can see from the Russia logo, currently the data sets in grid are accessible via Russia. Okay, so this diagram basically shows the backend architecture of ServiceX. So and basically ServiceX, all interactions to the backend is done via REST interface. And underneath there is a dataset finder for Russia dataset and pre-flight check to check the request is valid. And there's code generator to generate the code to be run in Transformer. And RabbitMQ basically manages all the transformation queues. And there are output layer of mini IO object store, and also there's Kafka message broker. So the output object can be stored in mini IO, and can be downloaded later on, or directly streamed to Kafka message broker and consumed later on. And whole service is, as I said, is running on the Kubernetes cluster, so it can be, deployed on large Kubernetes cluster near a big data storage center, or in principle, it can be deployed to your laptop, as I do quite often. And if you have installed Docker Desktop, and the different color scheme is for gray blocks are open source softwares, and the green are common for or code generator and transformers. And finally, these yellow blocks are essentially experiment specific or input data specific. The ServiceX Transformer, as I draw in this cartoon, I just want to emphasize what ServiceX, what Transformer does in general. So let's say you have a large root T3 file, and you want all the PT information of leading jet, and which passed the selection criteria I put here. And Transformer can deliver columns only the user wants, and after pre-selection. And also this output column can be basically converted into in the format you want. And this process can be quite effective especially if you need to extract a small subset from a large data set. So here I put a list of ServiceX transformers, and some are available now, and also their development. And every transformers are basically written in Python. They are based on Python language, but Atlas AUD transformer is essentially it executes C++ code. But the Omni transformer is, I would say, is more general transformer, as it takes flat tuple, or in principle it can take, as far as I know, CMS nano AUD as input. So non-Atlas or CMS folks can try this if their structure is flat tuple or can be read by Omni basically. And although it's not ready yet, CMS folks are working on CMS mini AOD transformer for now. And there's also PyRoot transformer, which is also beneficial as it has a full feature of root. So for example, if you want to save a root T3 with objects like TRNs vectors and so on, this PyRoot transformer does the job. And so in theory, you can have a transformer precisely optimized for your needs, and you can basically have your own transformer. Let me move to Frontend Library. So far, I talked about the backend of ServiceX, which you don't quite need to worry about in practical use. And now the Frontend Library is essentially this is the primary client library to access ServiceX backend. And in principle, you can directly interact with ServiceX backend through REST API or write your own frontend library, but I believe it's mainly for ServiceX developers. So here is the main features of ServiceX frontend. It accepts so-called Castle query for pre-selection and column selection. I should say that this Castle query is not intended for human to read or write straight away, but it's essentially has to be translated from a known language, and it supports the output in form of Akka array and pandas data frame and Apache Parquet and the root tuple, as I mentioned previously. And this frontend library can handle simultaneously queries. So you can make a query of 100 and then everything is run in parallel. and it starts to download as soon as transformation is done from the Kubernetes cluster. And it also supports local caching. So if you make it the same query repeatedly, and it basically uses cached file from your local drive. And ServiceX Frontend Library requires Python 3.6 or later, and maybe 3.7 for the latest version. And you definitely need ServiceX endpoints to make queries and download outputs. Okay, so yeah, now I want to try. I want to do the demo of the ServiceX Omni Transformer. So I want to try with flat tuple for Omni Transformer, and the data set size is 76 gigabytes, consists of 6 files. And I'm going to use ServiceX deployed an SSL River Kubernetes cluster. And the data set is stored at Atlas tier 2 grid site. And I'm gonna do the demo for this setup. So first, I need to have a ServiceX instance for Omni endpoint. So yeah, first is first. So I first have to import ServiceX, and then I need to have a data set for this Recast. And since it's a flat tuple, I need to specify the tree name or tree name of this tuple. And then I also have to specify the transformer image. Essentially, this is pulled from Docker Hub, and so this is so-called Omni Transformer. And then I make an instance of ServiceX and with the data set and image that I put, which is transformer, and the name of the tree. Let me execute. Okay. And then let's prepare a query. So as I said, ServiceX itself take a so-called Castle query, which is not, common or many of you aware. But yeah, there's we prepare something like TCA to Castle wrapper, so you can translate your TCA language into Castle and feed it to ServiceX. So this translator basically takes this is your, let's say, TCA selection, and then you need to list the columns you want to deliver. And then actually I need to connect to the ServiceX endpoint. And then I can basically make a recast. So make a ServiceX recast is done by this function. So if I do get data pandas data frame from the ServiceX instance that I created just in the previous slide, and then let me execute this. Hopefully it works. Yeah, while I'm waiting here, let me show you how this translator works. So this kind of, let's say, PT larger than lepton PT, first leading lepton PT larger than 20 GB, and this kind of selection query is essentially translated into, oh, right, I cannot do that. Let me stop here and try again. here you go. So yeah, first it start to it make a recast to the ServiceX and connect to the Kubernetes cluster. And then here you can see first line, it shows the dataset name, and it already starts to transformation. And you can see among six files of this dataset, and okay, 6 are done now. And at the same time, it start to download one whenever the output is available from the Kubernetes cluster, and it's already downloaded everything. And then let's check the output. So it's pandas data frame, and with I recasted 2 columns with leading lepton PT and subleading lepton PT, and with the selection. So after the selection, I have like 20K rows of these 2 columns of pandas data frame. And now basically you can interface this output for whatever you need. So you can interface to the machine learning if you don't want to do machine learning, or you can do his feeding, or just make a simple plot. So yeah, there we go. So yeah, you can make it like a simple plot out of the data set. So this workflow shows really 76 gigabyte is stored in somewhere in the grid, and you can make a recast like this is what I want, and make a query, and you can see how fast it is done. And then I also want to do another demo of Atlas XAOD transformation. So this is different. I'm going to use basically different transformer, right? So this is for this demo, the input is Atlas XAOD, and about the same size, 74 gigabyte, and it consists of 17 files. And also the ServiceX itself is deployed in the same cluster, and also DataSet is available there. And now let's have ServiceX instance for this XAOD endpoint. So here I put the dataset name, and the transformer image is now XAOD transformer. Now it's previously it was Umru transformer. And then for XAOD transformer, you don't need query name. And this query is this is the custom query. Let me execute this. And likewise, now you can basically make a recast or make a delivery recast, and you can make a recast in the pandas data frame, and also in the form of Aqua array, or you can make a recast to make it root file, and then it download to your local temporary directories, or you can specify the path you want to download. Let me try this out. Great. So likewise, you can see there the name of dataset, and it consists of 17 files, and it started now. While I'm waiting here, let me briefly explain what I have done. So first demo is essentially from the grid, which stores final flat interval, and use ServiceX deployment and access and deliver only the columns that I specified. And now basically also using the ServiceX, and now it is interfaced to the XAOD, Atlas XAOD, and basically doing the same. Okay, that's still running. It usually takes 1 or 2 minutes to be done. Let me just move to the next topic. So here I wanna discuss some ServiceX use case, and this is one of use case I worked on. So in Atlas we have so-called tracks feeder, which is a framework for bean template profile like fits. So it essentially does his fit, and it requires, yeah, we do need input histograms for this job. And generating input histograms for root entuples can be quite expensive, especially for very large entuples. And it takes, yeah, usually takes quite a long time if you have, yeah, like terabyte, yeah, input entuple. And this ServiceX can be used in that workflow and to accelerate the speed. So basically it reads a configuration file of the truck speeder, and then prepare ServiceX request, and then make a transformation request, and then ServiceX basically takes care of your selection based on configuration file, and then finally download the output files in the format of pandas or root file, and then convert into histograms also based on the configuration file. In this use case, you don't quite need to worry about storage issue. You don't need to store your huge entuple in your local area or somewhere. You don't need to worry about certain US area storage. And also at the same time, you can really easy to scale if you have enough large Kubernetes cluster. So the performance wise, it can be multiplied by number of available workers. So you can really accelerate this histogram extraction process using this ServiceX. And the other possible use case is, although I would say it is not a primary use case of ServiceX, but in principle, you can have a custom custom PyRoot transformer, and basically doing the entuple maker, like doing scheming and slimming of the root tree. And also, if you want to add new columns or branches into T-tree, like a full vector reconstructed top. And this can be this can be done pretty easy if you use ServiceX. And as I said, this is not primary use case, but it really shows the potential adaptability of ServiceX, that it can be really get placed in anywhere in the workflow. If I finish, let me check. Okay, it's done now. So it took about 2 minutes and 36 seconds to extract the GPT column out of 76 GB stored in the grid. So it's pretty impressive. So finally, before I close, we are very close to the public release of ServiceX, although we are not ready right now, but we are very close. So we are currently testing release candidate, and here is useful links you might want to have a look. So there's a ServiceX documentation, and you have a bunch of GitHub repos for ServiceX projects. Yeah, that's all from my side.
All right, thank you very much, Kyungeon. So let's see if this works. I'm going to try and share the questions. Okay, so first we have what kind of hardware setup is targeted by ServiceX? Will this run on the batch system of a specific institute, or specialized hard analysis facilities needed?
So as I said, it is running on Kubernetes cluster. So wherever you have available Kubernetes cluster, it should run out of box. But depending on your needs or what you want, you can put you might want to put close to the data center, because you need to essentially read the data from the grid. So having ServiceX deployed in Kubernetes cluster close to data center is, I would say, the optimal.
Okay. Then Lindsay asks, I know Kafka plus Spark allows us to distribute transformer results for processing in batch, but what about Dask, Parcel, or other distributed processing toolkits?
Oh, I guess I'm not a best person to answer this question. I don't know.
I mean, maybe it's worth to ask. I mean, at some level, this is a data distribution mechanism, right? Not so much a processing system.
Yeah, I mean, yeah. This main purpose is data delivery. So data delivery and not for, I mean, analysis, I would say. So the idea is this can be the output from the ServiceX. It can be attached to the analysis system. So you can do whatever you want, but having ServiceX, you can effectively reduce the network IO, so you can deliver smaller subset of data set which you want. I don't know if this answers.
Right. I guess what I'm asking is like, sorry for the echo. I guess, yeah, what I'm asking is, so with Spark, there's a nice interface with Kafka such that it automatically distributes data without repeating. But I'm not sure if the same mechanisms automatically work with Dask or, you know, just basic Condor jobs or stuff like that. So understanding how to glue the output of ServiceX to batch systems, regardless of what the technology of the batch system is actually kind of important, because that's what we need to do at the end of the day to get the analysis work out and make the histograms that we love so much. So I was just wondering if you knew how easy it is to access Kafka from Kafka or something else from any batch system while still maintaining this non-repetition property, so that you don't repeat data. That's like the most important fundamental thing that we need to maintain here. I haven't seen it really proven anywhere aside from Spark plus Kafka, which is a bit of a canned example.
I might just stop and say that this is a little bit of an independent question, because frankly, people who are actually testing this thing at the moment aren't using the Kafka delivery anyway.
Okay, I mean, so in that case, since you're testing it, what are you using it using to make sure that you don't repeat data? What kind of scale are you running it at, et cetera? That's what's underneath this.
Sure. Perhaps perhaps it's best to have a longer discussion.
All right, sure. I'll stop poking at you.
Well, I mean, it's a valid question. It's just this is a slightly orthogonal one. Okay, Jim, what's the procedure for registering a transformer? Is this envisaged as an experts-only feature, and hence there would be few used by many, or is it something that eventually everyone will be doing?
I believe it is, expert only feature, at least for now. But I think it's gonna be good to have, I mean, general, or how can I say, like a template transformer or something like that, so you can easily implement whatever you want. But but it's for, at least for now, it is it is expert only. It is not
Okay. And last question. So perhaps I missed some detail, but I'm wondering about differences between using ServiceX and the already existing root our data frame plus uproot, for instance. Why should we add another tool to our framework?
So this is the ServiceX not it is data delivery system. So it can deliver root. It can use, maybe we can make our data frame transformer and whatever transformer we need. But it is rather data delivery, but with some selection and column selection. So
All right, thanks. There are no other questions, I think, posted on the list. So thanks again, Kyungeon. And I think